In this video, we are going to learn about congruent figures. Congruent figures and congruence. Congruence is nothing but the state of being congruent. So let's see what is congruence now. Consider the case of a toy being made. I can call it a robo or a toy which looks like a bird and which simulates the functioning of a bird, that is, which simulates the flight of a bird. So two wings are given to this bird for this purpose, and maybe let me draw the beak so that it looks more like a bird. Yeah. And now the engineer who prepares these toys, his main concern would be to make these wings symmetrical, isn't it? By symmetrical, I mean they should look the same, exactly the same, both in appearance and in weight, because the weight matters a lot. The flight of the bird or the toy is hampered if the weight is not distributed equally among the two wings. And the appearance also, because of the aesthetic sense, and of course, mainly for the functioning of the toy. So, how does he go about doing this? Suppose the wings are made separately in numbers, in lots of wings, crores and crores of wings are manufactured so that toys are made. I've just drawn a slightly magnified size of the wing here to explain you better. So what should you keep in mind while making the wings so that they are one and the same, so that if one wing is placed on the other, they literally coincide. Of course, the property of one wing being placed on the other and coinciding with the other is called congruent. The wings are said to be congruent if you can superimpose one wing on the other and make it look the same. There is no protruding on any of these sides. Just like your passport size photographs. Have you ever measured your passport size photographs? Even if you take your friend's photograph, if your friend's photograph is taken and placed on yours, they coincide perfectly because the passport size photograph size, the length and the breadth are the same. So these is called congruence or congruent. Now here we are specifically going to learn about congruent triangles in the process of making the wings for this particular toy. So what does the engineer have to ensure? He has to see that one side, this side should be equal to this side, the sides marked in white, and the side marked in red should be equal to the side marked in red on the other wing also. I am just taking two wings for example, but he has to make lots and lots of wings like this. And what about the third one? Third one also, this, let me change the color once again. So this one should be equal to this side of the triangle. So, and is it enough? Is it enough if he ensures that the sides are equal? No, he has also to ensure that the angles, this angle has to be equal to this one, and the angle in white has to be equal to the angle in white in the other figure, and the angle in black has to be equal to the vertex angle, the angle in black in the other figure. So he has to ensure that 6 measures are always equal to make congruent triangles of wings. So how is he going to do this? Not necessarily that he has to measure all the 6 measures each and every time. Let's try and find shortcuts for that to help this engineer to make his wings, right? So consider these two angles. Let this be marked theta and the same angle theta. The measure of the angle is theta, and this line segment is equal to this line segment, and the one at the base also, they are equal. So what I represent in these two figures are congruent angles. Now that you have got a hang of what congruence is, you will know that these represent congruent angles. Now if the engineer knows that two of his sides are equal, that is, this side is equal to this and this side is equal to this, and if he also knows that the included angle theta is equal, then the only thing he has to check is the third side. When you combine, when you join the ends of these two line segments, and draw a line along that, you get the third side of the triangle. and this will be automatically found to be equal because the inclination of the angle is the same here, both here on top at the vertex and near the base, isn't it? That is, the angles made by the third side with this side and with this side are the same. If I call this angle as 1, this is also 1. If I call this angle as 2, this is also 2. And the third side, since they join these two sides, that is also equal. So, by ensuring that two sides of the wing and one angle, the included angle is equal, he can make congruent wings. He can make wings which are similar in all aspects. So now, by making the wings for this engineer, we have arrived at a postulate, the S.A.S. postulate, which says that if two sides of a triangle and one included angle is the same, then the triangles are congruent. Congruent in the sense they can be placed on the other. All those triangles which are made with the sides, two sides equal and the included angle equal, can just be kept on being placed on the other without any protruding anywhere. They exactly coincide with the other. So this is your famous S.A.S. postulate which we have arrived at. Once again I am saying, if two sides of a triangle and the included angle is equal, then it means that every side of the triangle, all the sides of the triangle and all the angles of the triangle correlate with the other. That is, the corresponding side, the corresponding parts of the triangle are all congruent. And your congruence, if I call this as ABC and this triangle as PQR, I can say that triangle ABC is congruent to triangle PQR. And remember what we started with, just with two sides and one included angle. Now we have arrived at side AB, or the measure of AB is equal to the measure of PQ. The measure line BC is equal to line QR, and line AC is equal to line PR. And not only that, we have also ensured that theta of course is the same. It was given already. Angle B is equal to angle Q was given. But now we see that angle A is equal to angle P and angle C is equal to angle Q. And this is what we call as corresponding parts of congruent triangles. Corresponding parts. AB corresponds to PQ. Line AC corresponds to PR. Right? So I hope you have followed this postulate now, S.A.S. Let's explore if there are any more conditions, meaning minimum number of things which we have to check so that the triangles become congruent. We'll do that in our next video. Thank you.